Okay, we're recording now, and I'm going to share my screen. There's the infinity screen. Okay, everybody can see this screen, correct? I should probably. Okay, thank you. And I'm going to actually divide it so I can see the chat because I want you all to interact with me on this. Okay, so we're going to take a look at the question that I consider to be the hardest question on exam 1, just because it's not so straightforward and you have to really know the definition and how it applies in this situation. So let's take a look at it. So this first question says, glucose diffuses slowly through artificial phospholipid bilayers. We know phospholipid bilayers are in the cell membrane. The cells lining the small intestine, however, rapidly move large quantities of glucose from glucose-rich food into their glucose-poor cytoplasm. Based on this information, which transport mechanism is most likely responsible for glucose transport in the intestinal cells? Okay, so how do we tackle this question? Does anyone want to share maybe how they did it or how they thought, what their thought process on this one was? Okay, so if not, then we will just start going over it together. So mark out the wrong answers. Glucose is big. Okay, yeah. So definitely those are two good things, and we will utilize both of those. So like Jessica said, glucose is a bigger molecule. So is it just going to be able to get through the membrane as easy as, say, like oxygen would? No, right? Because it's bigger, it's going to need a little bit more help. So we know that simple diffusion is probably not the answer here, right? Because we know that like oxygen, because it's small, it can like simply diffuse through the membrane. Like it can sneak by, as Dr. Arnett would say. But because glucose is larger, that's probably not going to be the case here. So like Morgan says, let's mark out simple diffusion. Okay, so let's take on the second part then of this question. So it says that we're moving large quantities of glucose from glucose-rich into glucose-poor. So if we were to reword that, we're moving from a high concentration to a low concentration. Okay, I'm sorry, Jonna. Maybe just if you need to come back in, if you need to leave and then come back in, that's okay. Is anyone else having audio problems or problems seeing my screen? I want to make sure that it's not my connection. It goes in and out. Okay, let me take a look. Okay. So it says that my internet is doing okay. And you can always come here to check your internets too. Okay, it's better now. Okay, we'll continue on, and hopefully it will resolve itself. If not, just let me know. And okay, a lot of people are having the same problem. Okay, but it's better now, correct? Yeah, okay. Thank you all for letting me know that. So did you all hear the part about glucose and how it's large so that it needs a little bit more help getting past the membrane? Okay, good. Okay, so now let's take a look at the second part. So it says we're moving from glucose-rich to glucose-poor. And if we're going to reword that, we're going from an area of high concentration to low concentration. So am I moving down gradient or against gradient? Going from an area of high concentration to low concentration. Correct. Good. Yeah, we're moving down gradient, right? We're moving with it. So is that characteristic of passive transport or active transport? Moving down gradient. Good. Very good. So that's passive, right? Because we're moving with the gradient, we're moving down gradient. We don't require ATP. So we can then mark out active transport, right? We know that's not an answer because we're not moving against the gradient. Okay, so we've marked out 2, and now we're coming down to the two that are left. So the 2 that are left then are facilitated diffusion and phagocytosis. Do you remember talking about phagocytosis during lecture? No, you don't remember it because we didn't talk about it. And anything that we don't talk about is probably not going to appear on the exam as a correct answer. So we can mark out phagocytosis. So the one that is left then is facilitated diffusion. And if you'll remember in your notes, when we talked about facilitated diffusion, glucose was the exact example that we used for that, right? We said that glucose is big, so it requires one of those protein channels for the carriers to get it past the membrane. So does this feel good? Kind of like how we went through the process, how we took a look at the question, and then we kind of marked out the answers one by one? Does that feel good? Okay, good. Okay. So now I'm going to stop sharing, and then I'm going to turn off the recording.